Okay, this is 12.6 quadratic functions. We're not going to do a lot with these, but we are going to basically make tables to graph. We're not going to graph today. We're going to look at some basics of quadratic functions, um, but we're not going to really get into it that much. The main skills I want you to have today is to be able to um, basically find what we call the axis of symmetry and then use that and make a table of values. Just kind of like we did when we first started graphing linear equations. We made a table of values, then we plotted those points and we graphed them. We're just not going to graph anything today. Okay, but a quadratic function is in this form. Y equals ax squared plus bx plus c, where a, b, and c are constants. These are actually called coefficients. Okay, and a is not zero. Meaning, if a was zero, I wouldn't have an x squared there. I would just have bx plus c, which would be a linear equation. So with any kind of quadratic equation, I must have um, this term. Okay, that's white. There we go. That's white. I don't have to have this term or this term. I do need this term for it to be a quadratic equation. Basically, I need that square on the variable. Okay? The graph of the function, a quadratic function, is a U-shaped curve called a parabola. We don't have to remember that. A quadratic function is an example of a nonlinear function. In other words, it does not form a line when we graph it. It forms kind of a U. Okay? A nonlinear function, any function whose graph is not a line. Okay, let's look at what a quadratic function looks like. This is a parabola. Okay? Now, what I want you to see here is when I change this number, this a is the coefficient of x squared. When I change that, look what happens. It kind of gets a little thinner, doesn't it? I'm just going up. Okay. Now, what I'm going to do is move it down a little bit. Okay. So there's 1. There's 0. Now, notice I lost the first term because we said a can't be 0 or we don't have a parabola. We got a line. Now, look what happens when it's negative. When it's negative, it's opening down. Okay. Going back, let's see, well, didn't mean to do that. Let's see, when it's positive, it opens up. See that, notice that this is positive, okay? This is positive. But when I go down, all of a sudden, this is negative and it's opening down, see? So when this first term is negative, we have a parabola that kind of opens downward. When the first term is positive, we have one that opens upward, which brings about the next little discussion here, the vertex, okay? The vertex is this point where the parabola changes direction. Okay, so it's coming up, hits the vertex, and then it starts going down. Okay, the vertex is where it changes direction. So today we're going to be looking at minimum and maximum values of parabolas. And what we have to know, when I notice this is negative, the vertex is the highest value of y that parabola gets. So we would call the vertex a maximum value because it comes up, hits the maximum, then starts going down. That's a maximum value. When it's positive, when the first term is positive here, notice that term's positive, the parabola actually opens up. So it's going down, down, hits the bottom vertex, and starts going up. So we would call this a minimum value. Minimum. Okay, so let me get a pen here. If it's opening up, this is a minimum value. If it's opening down, it's a maximum value. Okay. Another thing we need to know about this: there is an imaginary line here. In this case, it happens to be the y-axis that splits the parabola in half. Okay, that is called the axis of symmetry. Okay, axis of symmetry. Okay, once we find this axis, we know that we have half the parabola on one side and half on the other. Basically, this side is a mirror image of this. That's what's called the axis of symmetry. Basically, it's symmetric on both sides. Okay, so we're going to use this information here, and we're going to actually make a table for our graph. Notice another thing: when we make a table, if we find the axis of symmetry, we know that's halfway. So if I've got a table of values, the points over here should be the same as the points over here. Do you notice that? Okay, so at 1, we've got 2 here, but at -1, we've also got, I'm sorry, at x equals 2, we've got 0, and at x equals -2, we got 0. So they have the same y value. Okay, so on an axis of symmetry, something over here should mirror this over here. It should have the same y value. Okay, so let's look at a few basic things. The first thing we need to know is this. Okay, in a quadratic equation, the coefficient of x squared is called a. The coefficient of just x, or whatever variable is in there, is b, and the constant is c for constant, okay? Now, it is possible to have no middle term. In that case, b would be 0. It is possible to have no constant. In that case, c would be 0. It is not possible to have no first term because to be a quadratic equation, we have to have the square, okay? We have to have a degree of 2 there. So a is the first coefficient, b is the coefficient of the next term, and c is the constant. Okay, now what we're going to do is find that axis of symmetry. Now remember, axis of symmetry had a parabola, and the axis of symmetry cut it in half, basically. Okay, we're going to find that axis by using this formula, where b is this coefficient, a is this coefficient. That just means whatever the sign of b is, I'm going to change it. So I say opposite of b over 2a. Opposite of b over 2a. So that's negative b, but I just say opposite. Whatever b is, you change it over 2 times a. So that's the first thing we're going to do. So for this first one, notice that a is negative. Okay, it's actually negative 1. A is negative 1, b is 2, c is 1. Okay, so if I use the formula opposite of b over 2a, well, b is 2, so the opposite of 2 is negative 2. Okay, over 2 times a. Well, 2 times a is 2 times negative 1, which is negative 2. So when I simplify that, it becomes 1. So when I'm making a table, okay, make a table, that's not bad. I've had worse. This might be worse right here. No, I did it. And I'm going to make 5 values, okay. My middle number for x, we've got x and y here, my middle one's going to be that number, axis of symmetry, because whatever happens on this side of it is the same as what happens on this side. Okay, so I'm going to go up 2 and 3, then I'm going to go down 0 and negative 1. Okay, the next step is this. Okay, we are going to get, excuse me, get rid of this, and we're going to look at finding values. Okay, so if I place 0 is always the easiest thing to do. If I substitute 0 for x, let's get rid of this. That's 0 plus 0 plus 1. Well, if I substitute 0, I get 1 here, don't I? That's 1 for y. Okay, let's substitute 1. Well, 1 squared is 1, but this means what? This isn't, it's not like I'm squaring a negative. It's like I'm multiplying negative 1 times x squared. So if I square negative 1, I get a positive 1, but then I have to multiply, I'm sorry, let's do 1 first. If I square 1, I get a positive 1. Now multiply that, I end up getting negative 1. Okay, 1 times 2 is 2. So this is 3 plus negative 1, which is 2. Let's do negative 1. Okay, negative 1 squared is positive 1, but I multiply that positive 1 by negative 1, I get a negative 1 for the first term. 2 times negative 1 is negative 2. So this is negative 3 plus 1, which is negative 2, right? Now notice, it's going down here. This is a maximum value because the parabola is opening down, because this is negative. So the vertex, which is right here, is a maximum value, okay? A maximum value. So it's going to go down on this side of it, and it's going to go down on this side. But because this is the axis of symmetry, this is the same as this. So at 2, I've got a 1, and at 3, I've got a negative 2. It's just a mirror of what's happening over here. So I don't really have to work out these things to find out their values. Okay, and that's all we're doing today. We're just making a table. We find this, and then we make a table after we find it. Okay, it sounds really difficult. It's something different, something brand new, but it's really good to see these, just at least see these before next year, and to be able to make tables, because you will make a lot of tables next year. There are other ways to graph this, but it's really good to make a table. Okay, let's do this next one. Okay, I'm probably going to be able to do about one more of these and then move on, but or we can do this last one. It doesn't really matter. Let's do this one. Okay, opposite of b over 2a. Well, b is negative 4, so the opposite of b is 4 over 2 times 1. A is 1, so 2 times 1 is 2. That's going to be 2. So my table, my middle number will be 2. Okay, here, I don't care how you make your tables, up and down, sideways, that's fine. I do X and Y. My middle number is this, 2. Okay, so go down, 1, 0. Love having 0 in there, it's always easy. Then go 3 and 4. Okay, now we're done with that. It's my middle number, always the middle number. Okay, now I'm going to make a table. If X is 7, this goes away, and I've just got 7. I'm sorry, if X is 0, that goes away, I get 7. Now if X is 1, 1 squared is 1, minus 4 times 1 is 4, plus 7. 1 minus 4 is negative 3, plus 7 is positive 4. Okay, at 2, plug in 2 for X, I get 2 squared is 4, minus 4 times 2 is 8, plus 7. 4 minus 8 is negative 4, plus 7 is positive 3. Okay? Now, what's happening? This is the middle term, right? The axis of symmetry. So it's going to, these values are getting smaller. It hits this because it's a minimum value. They start going back up again. Well, from 3 it goes back to 4, and then 7. And there's my table. Okay? Made a table of values. Again, what I want you to be able to do today, even if you botch this up, you mess this up really bad, you get a different number. What I want you to be able to do is plug these numbers in here and get values for them. Okay, that's the skill we want to learn today. Not about graphing, not about doing anything else. I want you to have the skill of plugging numbers in to an equation or an expression and getting a value. Okay. We're going to have to skip those. We don't have time in this one for that. Now, tell whether the function has a maximum or minimum value. Now, I said whenever this thing is negative, you've got a parabola that opens like this. It's down. Okay. When it's positive, you have one that opens up. Okay. The vertex, in this case, if it opens down, the vertex is the maximum it gets. It's a maximum value that y gets. If it opens up, vertex is a minimum. Okay. So I look here. Is that negative? Yes, it's negative. Then it opens down. So the vertex is a maximum point. Okay? It has a maximum point. Now this one is positive, so it opens up. It has a minimum. Notice it doesn't have a maximum because these things keep going up, up, and up. They don't stop. So it has a minimum point. Okay? And this is negative. It opens down. It has a maximum point. No minimum because they just keep going down. So that would be a max. This is negative. It would be a maximum point. This is negative, it would be a maximum point. This is positive, it would be a minimum point. That's as hard as those get. Okay? Again, if it's negative, it opens down. The first term is negative, it opens down. That's a maximum point. The vertex is the maximum it gets. Okay? If it's positive, it opens upward. The vertex is a minimum point. Okay? Now, we didn't do a lot of examples today, but I think the 2 I did should explain just about everything you have to do. Okay? That's about all the time we have for this lesson.